Let's look at solving a Charles Law problem. If you remove a balloon with a volume of 105 milliliters of air, which is a gas, from a freezer at 0 degrees Celsius and allow the balloon to warm to room temperature, 25 degrees Celsius, what would its final volume be? Pause the video to solve this. So the very first thing we want to do is we want to identify what our variables are. So we have an initial condition where our initial volume is 105 milliliters and our initial temperature is 0 degrees Celsius. And then we are trying to find our final volume and we are given a final temperature. So looking at the equations for Charles' Law, this equation right here is the one we're going to use, where we're solving for the final volume. Now, one thing we notice is that our temperature is in Celsius, and that is not going to work. And we see here, that especially with a value of 0, that is absolutely not going to work. We can't divide by 0. So before we plug it into the equation, we've got to change our Celsius to Kelvin by adding the Celsius, by adding 273 to each temperature in Celsius. So our initial temperature is 273 Kelvin, and our final temperature is 298 Kelvin. So when we plug our values in, our initial volume times our final temperature divided by our initial temperature, we see our units of Kelvin cancel out. We're left with units of milliliters, which is what we're solving for. I mean, it's the physical property we're solving for, which is volume. And multiply 105 by 298 divided by 273, we get an answer of 115 milliliters. And does this make sense? Yes, it makes sense, because as our temperature goes up from 273 to 298, we would expect our volume to increase as well, and that's exactly what we see. So just a word of advice, please remember to include your units when you plug in. They will help you keep track of whether you've set it up correctly. Yeah, so always include your units.